Hi, I'm Dr. Jennifer Moses, and today we're going to walk through our first guide for learning PSPP, which is the free open source version of SPSS, which is the most common sort of foundational statistical analysis program in the behavioral sciences. So the first thing I want to, and so what I'm going to be walking through is actually a flow chart, like a step-by-step guide that I've created. And we're going to start with the basics and then move on to graphs. So the first thing I want you to know about PSPP is it's got two different views. It's similar to Excel if you've ever used Excel, but it's got some much more advanced features. And so it's got two different ways you can view data. It's what's called data view, where you would actually see the actual data for whatever it is you're researching. In my case, it looks like I have two what are called variables here, called height and weight, where each column then is a different variable, some characteristic on which my observations can differ. I'm a psychologist, so my observations are going to be people. So here in the first column is a row of numbers, 1, 2, 3, 4. Those refer to the individual people. So person 1, person 2, person 3, and then I have a row of heights for all the different people, and then I have a row of, column of heights for all the different people, and then a column of weights for all the different people. And then, of course, I could have a third variable, a fourth variable, where again, variable means some human characteristic. It doesn't have to be people. You could be having a bunch of yeast specimens if you're a biologist, or a bunch of trees if you're a botanist, or who knows what. But I'm a psychologist, so for me, my observations are people, and I have the heights of a bunch of people and the weights of a bunch of people. If I click, but there's also something called variable view, where if you click down here on variable view, that will basically have a bunch of different characteristics for your variables, the ways that people can be different. So now this is this whole row is all about height, this whole row is all about weight, and this is the characteristics of those two different variables that I created, height and weight. And there's a number of different things that you can go through for variables. Name, type, width, decimal, label, value labels, missing values, columns, align, measure, and roll. And I have a little brief description here of what you might interact with. Like, for example, if you want to change the type of your variable, the two most common are numeric and string. Both height and weight are numeric variables because they're numbers. I like to think of variables as questions that you ask people. So one might ask someone how tall they are, and the number that they give back is going to be a number, so a numerical response, where the number has some meaning. So 62 inches, 67 inches, 74 inches, 80 inches, whatever it is. Weight is also numeric, 120 pounds, 100 pounds, 160 pounds, 300 pounds, whatever it is. So it's numeric, but it need not be numeric. The most common way to be different from numeric is string. Essentially, comma, dot, scientific are all just different ways of notating a numerical response. But string is quite different. String is when you've asked someone a question and you don't want to and their answer to that question is not a number. It's a word, like, do you drive a car? Yes or no? What's your favorite color? Red. And you don't want to actually have to assign numbers to all the different values. PSPP gives you that option. If you want to just type in red, you can specify a string. The unfortunate thing about choosing string is it doesn't allow you to manipulate the data, right? Only numerical responses allow you to manipulate the data. So even if you have like a response that's a word, like male or female, or intersex, or are you a man or a woman, or non-binary, you might want to assign a number to it and still consider it numeric. Because then you can manipulate your data. Like you might assign gender neutral as 1, and woman as 2, and man as 3, and that would still be a numeric response. String is when you just want to type a word into the file without any data analytic capability. And so then here's, so you have a little blurb here, a little description of what each of those variable characteristics, what they refer to. So there are also functions in PSPP. So at the top here, you'll see all the different functions. The only one we're going to go over today is graphs, because this is the first, just an example of the things that you can do in PSPP. And in different future guides, I'll go over other possible analyses in PSPP. So you're going to click on graphs, and let's just try to make a histogram. So step 1, click on graph. Step 2, click on histogram, and this little pop-up window is going to be seen. And you'll have all the different variables that you've created on the left here, and then you use this little arrow here to pop your variable into this empty field. You can pop variables back and forth. And you have the option, a histogram is a visual representation of quantitative data. Quantitative data is whenever you've asked someone, again, a number that is, asked them a question about a variable that is a number like height or weight or how fast can you run a mile. You'll have a whole big group of people, and then you can get a visual understanding of how all of your people look by making a histogram. So I click on, let's just do height. So I click height and I pop it into there. And then I can choose to display what's called the normal bell-shaped curve over my histogram if I want by toggling this on and off. Then I click OK. And bada bing, bada boom, I'm going to have a height histogram pop out in my output file. So a separate file will open called the output file where you'll see your histogram. So what if you want to share your histogram with somebody else? Well, unfortunately, you can't just save the output file. You'll have to actually export it as some sort of image file. So you'll go to File at this point and click Export. You'll think of a name for your histogram, and then you'll have to choose from a drop-down menu, PDF. It's got to be a PDF. None of the other options are image files. So if you want to actually share your histogram with somebody else, you'll need to choose the PDF. Come up with some interesting name and choose some logical place to put your file. I have a file on my desktop called PSPP graphs, and that's where I'm going to choose to save this histogram output picture. Click Save after I've chosen PDF, right, and then it should then be saved in your in that file. The other thing you might want to do is you might want to save your data file. Like you might be inputting raw data, and so you might want to then save it. So in this case, you're not going to be saving the output file, but the data file itself. So you'll go to File, Save As, and again, come up with some interesting name, some name that you like, put it in some place that makes sense, maybe with your PSPP graphs, and it's going to be a system file. Don't change that. Click Save, and that's going to save your file. So now I'm going to walk through all these different functions for you in an actual program of PSPP. I'm going to show you two different ones, so bear with me for a second. So what I've pulled up for you here is the data set called example data set, and it's just for me to play around with. So here's data view, and see I've got all these heights and all these weights, and then variable view, height and weight. So I'll click back here to data view. And then variable view. And as you can see, I haven't really done much here in the variables. So first thing I'm going to do is just show you how to make the histogram. Go to Graphs, Histogram. Let's choose height, variable. I'm going to display the normal curve. Click OK. And then again, a separate file pops up. Called the output file that shows you that histogram, and I chose that normal curve. So again, if I want to export this, File, Export, this pops up. Right. I've already saved this previous time, but I'm going to go ahead and call it histogram height. I need to tell it it needs to be a PDF. Let's call it histogram height 2, new file, it's a PDF. Save, save, and I'm going to go ahead and show you where that is and what it looks like as an output file. So here is that little folder I've made for myself. I like to put something in a rational place. So right on my desktop, I have a folder called PSPP graphs where I put data files. And as you can see, here's that histogram 2. Go ahead and open it up. And here it is, right? It already has some statistics there for you, but here's that beautiful PDF of that histogram that you could share with somebody else. And it like tells you what variable it was, what data set it came from. All right, so I'm going to use a different data set now to show you how to sort of input data. So this is a data set that I've actually, that comes from a survey I give to my students. And I'm already here in variable view. And as you can see, these are the variable names: age, SIBS, major, height, right? So this is the name of the different variables. But here I have the type, numeric versus string. And what I've chosen to do is anything that I call a quantitative variable, quantitative, I've made a numeric variable, numeric type. And anything that's what's called a qualitative variable, I've made a string. So age, I'm, 76 years old. I'm not really, but whatever. Is numeric. Number of siblings I have, I have, 16 siblings, 19 and counting, whatever. That's numeric. But major, psychology, is a string variable because it is a word, right? So again, so here I've got 1 decimal place after for age, 2 for siblings, and then you can see with my label here, I've actually put the entire question that I asked my students in the label to remind myself what was GPA. Oh, I asked them what their GPA was. What was VACA? I asked them if you were going to go on vacation, where would you go? And so I've asked them these series of questions. So the label option is actually really nice for reminding yourself what these short variable names mean. Variable labels, again, are used when you want to take what should be a string variable and make it numeric so you can manipulate it. You would then here say 1 equals, for like major, 1 equals psychology, 2 equals engineering, 3 equals pre-law, or what have you. Align, you can align left or the right. I always do right alignment, it's easier. Measurement is the other one that might be interesting. We're going to have, you have 3 options for measurement. There's a little drop-down menu. You can choose between nominal, ordinal, or scale. And for those who are familiar with statistics at all, there are 4 what are called scales of measurement. You can really classify all data into what's called quantitative, numeric, or qualitative, which is like a string. Is it a number? Quantitative, you're asking someone a question. Is the answer a number? That's quantitative. Or you're asking someone a question, is the answer a word, right? Quantitative would be age, siblings, on a scale of 1 to 10, how much do you love your dog? Whereas string would be anything, or qualitative would be anything where you're putting people into groups. So do you drive a car, yes or no? What's your favorite color, purple, red, or yellow, whatever. But scales of measurement are like a more fine-tuned way of describing the nature of your variables. And it's based on this guy, Stevens, 1946, who came up with 4 scales of measurement: nominal, ordinal, interval, or ratio. And so PSPP allows you to specify whether you're choosing numeric or string, whether or not you're dealing with a nominal variable, which could be either a string or a value labeled numeric; ordinal, where you're putting people in order, 1, 2, 3, or 4, like the places in a race; or something that's rigorously mathematically assessed, which would either be what he calls interval or ratio measurement, where you're measuring something numeric about somebody, you're measuring something what we call quantitative in a rigorous fashion, such that all the different points along a number line have the same distance between them. Like how fast can you run a mile? 1 minute, 2 minutes, the difference between 1 and 2 is the same. Or temperature, where the difference between 1 degree, 2 degrees, and 3 degrees is all the same. So you would use scale for either interval or ratio measurement, and then nominal for nominal measurement and ordinal for ordinal. So there's in my class, this actually really mirrors how I teach students in my class. Numeric versus string is like quantitative versus qualitative, and then nominal, ordinal, or interval or ratio are sort of treated the same by PSPP. So that's sort of the data view for like a real sophisticated survey. And as you can see in my survey, I've asked lots and lots of questions. I've asked my students 60 different questions. And this is the variable view, looking at those 60 different variables and the nature of them. Click over to data view, and you can see you have those short names at the top, but if you mouse over, it actually shows you the specific question I asked, because I was smart and put the specific question I asked under variable view. Here is gender. What did I actually ask? What I actually asked is, what is your gender identity? Pro N is, what are your preferred pronouns? Ethnicity, what is your race, ethnicity? Job, do you have a job, yes or no? GPA, I asked them their GPA, right? So those are the different options. So now I'm going to just enter some data. And the biggest thing to know is when you go into these cells, you make sure the cursor is blinking. And so this would be person 5. I'll put in that they're 36. And you actually have to press enter. Otherwise, the data won't get saved. Same thing here for major. I've done this as a string. Let's say this is a law major. You have to click in there, make sure the cursor, and click all the way to the left. Make sure the cursor is blinking. Type in law and then press enter, and then the data is saved. And so if you've previously typed into a cell, you just have to make sure your cursor is all the way to the left, and then you can type something freely into the cell, right? See how some of them have little dots and some of them don't? If they have little dots, that means you've interacted with the cell before, and if you want to type something in, you actually have to delete the dot because the dot indicates missing data. It's kind of one of those weird things about PSPP. If you haven't interacted with a cell before, you can just click in it and it's like, okay, here I am. And you can just type whatever, right? Like my major is, I don't know, engineering, right? And then I could just press enter. But if I've interacted with a cell before, I have to delete the little period there. Super irritating, but true. And then you can press enter to have the data preserved. And so now if I want to save this data file that I've interacted with, I would go to File, Save As, and I've got Student Survey here, and I'm going to just let's save it as Student Survey Data 2, and then I can press, it's a system file, don't change that, press Save, and then it's saved. I'm going to go ahead and shut this down and reopen it so we can get a sense of what that looks like, make sure it was actually saved. So now I've shut down that file, and there's my guide back. So now I'm going to go to the folder where I saved it, and I saved it somewhere smart like desktop. So now I'm going to go back to that folder. On my desktop. I'm going to go to desktop and PSPP graphs. Let me just pull that into the frame so you can see. I've got my 2 different versions of the histogram and 2 different versions of the data set. I'm going to go ahead and open up the data set. Bam, there it is. Let's go to data view. And there you can see all that stuff that I typed in is all saved. English, law, right? That new stuff. All right, so if we go quickly, so that is the guide for the basics, how to orient yourself in PSPP, enter data into PSPP, how to make and save a histogram, and how to alter data and then save the data. I hope you found this tutorial helpful. Dr. Jenny signing off.